Okay, so we're counting atoms for those of you who have been in class or been quarantined or not. This is how we count atoms. And we have had some notes and went over some stuff in class on this and did some examples. And there are some examples on those notes that show you the correct answers. But I'm going to go through the bottom of our notes where it says examples. There are 3 examples. And I'm going to do that with us as a model for you to see how we can count atoms. And I've actually used some color coding to help us understand the parts of a chemical formula so we can actually break it down into the pieces of counting atoms. And so we have groups that are usually organized by numbers in some way. And so I say groups to kind of go back to our mathematical principles of when we do multiplication, we're talking about groups of, it could be groups of 4 or groups of 6. We might be talking about groups of oxygen or groups of carbon, or even groups of something like you might see carbonate, which is 1 carbon and 3 oxygen. So I'll show you how that works here in this video, and we'll do these 3 examples, and hopefully you can use this to help you have success on the examples in our practice and preparing for our next quiz over counting atoms the week we get back from Thanksgiving. Our first compound is called glucose. And so the first thing we do in any chemical formula is we identify what elements are in the chemical. So we're looking at capital letters, which is what we saw in our notes as the first important thing. C, H, and O are all capital letters. And then we have a periodic table available, which you can find online, or you can use the one we did in class earlier this year that's yours, that we never took up. And that's where it's going to get your name of each element. So we know that carbon is the element for C, hydrogen is the element for H, and oxygen is the element for O. And then the second thing we do is we look at the subscripts. We talked about sub means below, like submarine, or substitute is not the same thing. It's not the same as the original. So subscript is a script that's below the element, and it describes. That's what a script kind of does, is it tells us what to do when we're acting or when we're saying something. So it describes the element, and it's a number that describes how many of that element we have. So each of these subscripts tells us the number of each element. So we have 6 carbon, 12 hydrogen, and 6 oxygen. Okay. And then it's kind of simple, but whenever you see the word total, total means to sum or to add all together. So the total number of atoms, what are we going to do mathematically? We are going to add them together. Okay. So 6 plus 12 plus 6. And that's going to give us our total number of atoms. That's 12 plus 12. That is 24 atoms. And that's how you do number 1, which is kind of our basic example. Now, number 2 is similar, but now we have this lowercase letter. And so a lowercase letter is important because it shows us that it's still only one element. It's not a new element. We only identify elements present based on their capital letters in the chemical formula. So Ca is a symbol for one element because it has one capital letter. And that element happens to be calcium, which we'll find on the periodic table. And then we have carbon, just like before, and we have oxygen. Now we're going to look at the subscripts. There is not one for calcium. There is not one for carbon. And so since there is not a number there, the only number available is 1. It's not 0, because if it was 0, then the element would not even be in the formula. So if there's not a subscript, we know that there's only one of those elements. So we have 1 calcium, 1 carbon, and then our subscripts tells us that we have 3 oxygen. And then we add those together. 1 plus 1 is 2, plus 3 is 5. Okay. Now, number 3 is the most challenging example of a compound. And that is because it has two of the grouping things that I talked about in them, and they are colored differently. So the first one is in green, and it is just a subscript, just like our numbers that are in blue. A subscript describes what's in front of it. This green subscript here is describing what's inside of the parentheses, or some people might call them brackets. And that means that we are going to have two of whatever is in those parentheses. And in my class, we always say that parentheses are packages. Kind of like when you order something from Amazon and multiple things come in one box. That's kind of how the parentheses work. Those are something called polyatomic ions that we don't have to know about, but they hold that many elements in each package. And so inside of the parentheses, I have one nitrogen and oxygen, and there's three of those. And that is what is in each parenthesis or each box. So I have two of those packages or two of those boxes. So I would have to multiply. So it's a group, basically. I have two groups of NO3. And so how many individual elements are in both of those groups? That's what we will be looking for. Let's go back to the very basic thing before we even get into that. I know I started off with the new things, but let's just first say what elements are in this, okay? So lead is Pb. That is a lowercase b, so lead is one of those elements. Nitrogen is the other, and then oxygen is the O, right? And so we were just describing, if I look at this, there's nothing underneath lead, so there's only one lead. And I'm actually going to put parentheses here because I want to show you how we're thinking mathematically. So I have one lead to start with. And then nitrogen, I have one nitrogen to start with. Right? When I look underneath it, there's no subscript. And then I have, when I look at the subscript for oxygen, I have 3 oxygen. And so I'm going to actually highlight this in blue. And I know these are not in blue because there's not a subscript, but I'm going to make them blue because that's what we're doing is we're looking at just the subscript right next to the element, right? Now, lead, I'm not going to do anything with lead. It is by what it is. So there's only one there. But I have an issue a little bit because I have this green subscript of 2 that describes what's in the parentheses. So it tells me that I have 2 of those groups. I have 2 groups of NO3. And so I'm going to have to multiply because there is 1 nitrogen in each group. So I'm doing 1 times, and I'm going to change the color so you see where I get this number, 1 times 2, to find out how many nitrogen do I have. I have 1 times 2. So I have 2 nitrogen total in lead nitrate. And I'm going to actually multiply this oxygen also by 2 because I have 2 oxygen in lead nitrate. So in 1 molecule of lead nitrate, this formula, I have 1 lead, because it's subscript, 2 times 1 is 2, because I have 1 nitrogen in 2 groups of nitrate, and I have 6 oxygen because I have 3 oxygen in 2 groups of nitrate in lead nitrate. Now, very last thing that you're going to want to do is look at the number that's in front of the entire chemical formula. That is called a coefficient. Co means together or with. And so the 2 is telling me how many molecules of lead nitrate do I have. So the last thing we're going to do is we're going to multiply the whole thing by 2 because that's how many molecules we have. And so I'm going to illustrate that by using the color red and color coding that here. And that shows us kind of our mathematical thinking here. So we have 1 lead in 1 molecule of lead nitrate. One lead in 1 molecule, but we have 2 lead nitrates, because that's what that 2 is telling us. There are 2 molecules. So 1 times 2 is 2 atoms of lead. 1 times 2, because I have 2 nitrates in lead nitrates, and then I have 2 lead nitrates. So that's 1 times 2 is 2, times 2 is 4 nitrogen. And then we have 3 oxygen in 1 package or 1 parentheses of nitrate. And we have 2 nitrates in lead nitrate. So that's 3 times 2, that's 6, times 2 molecules of lead nitrate. So I would have 6 times 2 is 12. 12 oxygen. So I have 2 lead, 4 nitrogen, 12 oxygen, and then I add those together and I would get 18 total elements. So when you see questions like this is the order that you would follow for these chemical formulas. First thing you're going to do, identify the elements using capital letters. The second thing you're going to do is find the subscripts and find out how many of each element you have originally. Third thing, if you have parentheses, make sure you multiply what's inside the parentheses by the subscript for what's in the parentheses, because that's how many packages you have. So you have to say how many groups. Well, I have 2 groups of nitrate. So I have to multiply each object by 2. Okay? And at the very end, if there's a number in front of the entire chemical formula, take your total number of atoms for each element and just multiply it by whatever that number is. So we took 1 and multiplied by 2. We took 2, multiplied by 2. We took 6 and multiplied by 2. And that's how we got our answer. If that was a 3, we'd simply replace our red number here with 3, and we'd get 3, 6, and 18. It'd be different numbers. So hopefully that helps you out in your thinking process, and the color coding hopefully helps you see what we did with each part of the chemical formula. Good luck on practicing atoms over Thanksgiving break. Don't work too hard. Make sure you stay safe. And hopefully this will help us out as we continue to work on counting atoms to finish up this unit. See you guys later. Have a good one. Bye.